Chemistry of the atmosphere. First, what is atmosphere? An atmosphere is a layer or a set of layers of gases surrounding a planet or other material body that is held in place by the gravity of that body.
The composition of the atmosphere. The atmosphere is composed of a mix of several different gases in differing amounts. The atmosphere consists mainly of nitrogen and oxygen. Composition of the atmosphere. Atmosphere is maintained through a balance between processes such as photosynthesis, respiration, and combustion. But human activities are polluting the atmosphere. Photosynthesis by plants is thought to be a key process in the evolution of the Earth's atmosphere. You need to know the proportion of the main gases in the atmosphere. The Earth's atmosphere has remained much the same for the past 200 million years. The composition of air. It is clear that the main gas is nitrogen at 78%. Oxygen is the next most abundant gas at 21%. The remaining gases are found in much smaller proportion. These include carbon dioxide.
Air pollution. Air pollution can be defined as the presence of toxic chemicals or compounds, including those of biological origin in the air, at levels that pose a health risk. In an even broader sense, air pollution means the presence of chemicals or compounds in the air which are usually not present and which lower the quality of the air or cause detrimental changes to the quality of life, such as the damaging of the ozone layer or causing global warming.
There are 6 common types of air pollutants: carbon monoxide, ground-level ozone, lead, nitrogen dioxide, particulate matter, sulfur dioxide. Carbon monoxide. Carbon monoxide came from fuel combustion of vehicles and engines. It reduces the amount of oxygen reaching the body's organs and tissues. It also aggravates heart disease, resulting in chest pain and other symptoms. Ground-level ozone. It is the secondary pollutant formed by chemical reaction of volatile organic compounds and in the presence of sunlight. Ground-level ozone decreases lung function and causes respiratory symptoms such as coughing and shortness of breath, and also make asthma and other lung diseases get worse. Lead usually came from smelters, a metal refinery, and other metal industries such as combustion of leaded gasoline in piston engine aircraft, waste incinerators or waste burners, and battery manufacturing. It damages the developing nervous system, resulting in IQ loss and impacts on learning, memory, and behavior in children, cardiovascular and renal effects in adults, and early effects related to anemia. Nitrogen dioxide, formed by fuel combustion from electric utilities, big industrial boilers, vehicles, and wood burning. Nitrogen dioxide can worsen lung diseases leading to respiratory symptoms, increased susceptibility to respiratory infection. Particulate matter. It is formed through chemical reaction, fuel combustion such as burning coal, industrial processes, farming, and unpaved road or during road constructions. Short-term exposure to this can worsen heart or lung diseases and cause respiratory problems. Long-term exposure can cause heart or lung disease and sometimes premature deaths. Sulfur dioxide. It comes from fuel combustion, especially high sulfur coal, electric utilities, and industrial processes, as well as natural occurrences like volcanoes. It aggravates asthma and makes breathing difficult. It also contributes to particle formation with associated health effects.
Global warming. Global warming is the phenomenon of increasing average air temperature near the surface of Earth over the past 1 to 2 centuries. Climate scientists have since the mid-20th century gathered detailed observations of various weather phenomena such as temperatures, precipitation, and storms, and of related influences on climate, such as ocean currents and the atmosphere's chemical composition. These data indicate that Earth's climate has changed over almost every conceivable timescale since the beginning of geologic time, and that the influence of human activities since at least the beginning of the Industrial Revolution has been deeply woven into the very fabric of climate change.
The consequences of global warming. The consequences of changing the natural atmospheric greenhouse are difficult to predict, but certain effects seem likely. On average, Earth will become warmer. Some regions may welcome warmer temperatures, but others may not. Warmer conditions will probably lead to more evaporation and precipitation overall, but individual regions will vary, some becoming wetter and others drier. A stronger greenhouse effect will probably warm the oceans and partially melt glaciers and other ice, increasing sea level. Ocean water also will expand if it warms, contributing to further sea level rise. We must think at least one way to solve or prevent the global warming. Chemistry of water. What is water? A colorless, transparent, odorless, tasteless liquid that forms the seas, lakes, rivers, and rain, and is the basis of the fluids of living organisms. Characteristics of water. Water has three characteristics: physical, chemical, biological.
The physical characteristics. Turbidity. The turbidity is measured by a turbidity rod or by a turbidity meter with optical observations, and this expresses the amount of suspended matter in milligram or liter or in parts per million. Color. The presence of color in water is not objectionable from health point of view, but may spoil the color of the clothes being washed. The standard unit of color is that which is produced by 1 milligram of platinum cobalt dissolved in 1 liter of distilled water. Taste and odor. The extent of taste or odor present in a particular sample of water is measured by a term called odor intensity, which is related with the threshold odor or the threshold odor number. Temperature of water. For potable water, temperature of about 2 Celsius is desirable. It should not be more than 4 Celsius. Specific conductivity. The total amount of dissolved salts present in water can be easily estimated by measuring the specific conductivity of water.
Chemical characteristics. Hardness is caused by the soluble salts of calcium, magnesium, iron, manganese, sodium, sulfates, chlorides, and nitrates. The degree of hardness depends on the type and amount of impurities present in the water. Alkalinity is usually equivalent to the carbonate hardness. Sodium, however, also causes alkalinity. In natural waters, sodium is not normally present in appreciable amounts.
Biological characteristic. Bacteria are among the most common microorganisms in water.
Different types of water. Tap water is the water that you get directly from your faucet, while mineral water is the water that naturally contains minerals. Spring water. Natural springs are not passed through a community water system and are yet considered suitable for drinking as it comes from under the ground. Well water. In rural areas, one of the primary sources of water is what is dug out from deep wells. Deep wells directly tap groundwater and bring it to the surface from which people can take their water. Purified water is the water which, after deriving from its source, has underwent purification treatment in a plant. Distilled water or demineralized water is one where the water has been subjected to a treatment that removes all its minerals and salt by the process of reverse osmosis and distillation. Sparkling water is the water that has undergone carbonation, which makes your water fizzy just like your sodas.
Different processes in water treatment plant. These are the 5 different processes in treatment of water. Number 1, chemical coagulation. Number 2, flocculation. Number 3, sedimentation. Number 4, disinfection. And lastly, filtration.
Water quality standards are the foundation of the water quality-based control program mandated by the Clean Water Act. Different types of water contaminants. Biological contaminants. These include organisms that live in water like bacteria, parasites, viruses, and protozoan. Most of these include microorganisms or organisms that are so small they cannot be seen with the naked eye. Chemical contaminants. These include compounds or elements found in water like metals, salts, toxins, pesticides, bleach, and more. Physical contaminants. These change the physical properties or appearance of water. It includes sediment and other organic matter. Physically contaminated water can be visually identified without having to perform testing. Radiological contaminants. Unstable chemical elements with an unbalanced amount of neutrons or protons can cause a radiological contamination like uranium, plutonium, or cesium. Radiation is incredibly hazardous to your health.
How does these contaminants in water affect humans? You will get a stomach ache at the least. Waterborne diseases account for the deaths of 3,575,000 people a year. That's equivalent to a jumbo jet crashing every hour, and the majority of these are children.